All right, go take your homework out and turn in your textbooks to page 91. Page 91. I want to start by looking at the word problem that you did for homework, word problem 61. And go ahead and read word problem 61 for us, if you would. Noah, nice and loud.
Michael Beasley invested $10,000 for 1 year, part at 10% annual interest and part at 14% annual interest. His total interest for the year was $1,280. How much money did he invest at each rate?
All right, so the two unknowns here, Maddie, were how much he invested. I'm sorry? Part one and part two. So part of his investment, and then the other part of his investment. You could do it that way, really up to you. The headings for our chart should be what, Brecken? Good. Now, technically T, right? PRT equals I, but the time is a year, so we can kind of leave that alone and just remember that as long as time is a year, P times R equals I. Clearly spelled out for us are the rates for these two investments, Maddie. 10 and 14? I'm sorry? Oh, 0.10 and 0.14. Okay, I'm sorry, I didn't hear the decimal point there. And in order to get the interest, we would need to figure out the principal, and we would just multiply. How do we represent the principal here, Noah?
X and 10,000 minus X.
All right, good. X and 10,000 minus X. Technically, it could be either way. I had given you the recommendation that allow the biggest one to be X, but for sake of showing it, since we don't do it often, let's go ahead and just show it without the bigger one being X, so that it does still work. And then for our interest column, how would we fill that in then, Brecken?
0.10 times X and 0.14 times 10,000 minus X.
And so obviously he has two different investments. The one investment earns him this much money. This is the interest he makes off of it. This is the interest he makes off the other. The number we haven't used yet, Maddie, is the... and that is his total interest for the year. Not from this one, but from both of them together. So our equation should be... All right, and as is going to happen every time we have an interest problem, we're going to have decimal places. We're going to have to move the decimal. How many times, class? 2. And what does the equation become when I move it 2 places everywhere? Noah?
10x plus 14 times 10,000 minus X equals 129,000.
All right, and of course the next thing we would need to do here, Brecken, is go ahead and distribute to get 10x plus... what's 1 times 14? There we go, 140,000. Yeah, so we just tack on the 4 zeros at the tail end of the 14, and then 14 times the negative x. All right, equals 128,000. Of course, we'll combine our x's together to get what here, Noah? Negative 4x. Now, here's the thought. I don't want negative 4x. So if I get the negative 4x and immediately move it over, it would become, class, positive 4x. And in that case, Maddie, I would need to move the... which I'd rather move anyway, because I don't like subtracting big from small and getting negative. So let's also move the 128,000 over as a negative to get 12,000. And if 12,000 is equal to 4x, then x would equal anyone? 3,000. Now, that may not have been what you got for x. How many did get x was 3,000? How many got x was 7,000? Oh, that's what you should have gotten if you had the other way around. Because if you called this x, you wouldn't have gotten 3,000. I called this x, so $3,000 is how much he invested at 10%. The rest of his 10,000, which would have been 7,000, he invested at 14%. So, as you called this x, you should have gotten 7,000. And then of course 3,000 here, same answers. What happened? We didn't get it?
On the 128,000,
Mm-hmm.
I wrote it down, and my 8 looked like a 0, so what did I got?
So you had 20,000 equals, well, maybe 20,000 equals 4x, where you would have gotten 5,000. Or if you had it the other way around, it would have been 10,000 equals 4x, you would have 2,500, something weird like that. Okay.
At the very beginning, I put 1,280 minus x.
Okay, so you treat it like the 1280 was what he invested, as opposed to 10,000 is what he invested. 1280 is what he got out of it, okay? Maddie? They say great minds think alike. We're changing the definition of great here. Every time he makes some bonehead mistake, you go and do the same. You sure you're not copying off his homework, are you? Okay, all right. Y'all been in the same class way too long. All right, let's turn to page 129. Let's turn to page 129. Did you learn from the mistakes at least? All right. Maddie's writing down a note to herself. Don't do what Noah does. Be a great note to write. Or maybe it's the other way around. Maybe he's doing what she does. Mm-hmm. All right. All right, page 129 in your textbooks. And let's go and take a look at numbers 15, 17, 19, 22, 29, and 30. Number 15, 17, and 19. You were saying which of those solutions are actually solutions to the inequality? Number 15, x negative 7 is greater than or equal to negative 2. Which of those solutions actually work? Bracken? The 5 and 6, because 5 is exactly equal to negative 2 when you plug the 5 in. When you plug the 6, you get negative 1, which, yes, is greater than negative 2. Number 17, Noah.
The last one.
Just the last one, which is what? 4. Yeah, just the 4, because 2 times 4 is 8, plus 4 is 12, which is greater than 10. Plugging in the 3, we get you 10, but that's not greater than 10. It's equal to, and that wasn't an option. Number 19, what did you get, Maddie? The 2 and 6. Because again, really, there's only one thing it can't be. It just can't be the 4, because you plug in the 4, you 1, plus 3 is 4. That's the only thing it really couldn't be. Anything else would be good to go there. Did we get those correct? 15, 17, 19? Question? You understand it now? All right, turn the page. Let's take a look at 22, 29, and 30. It says, Todd is 5 years older than his sister Anne. The sum of their ages is less than 15. Could Anne be 9 years old? Well, first we want to write the inequality. If Todd is 5 years younger than, or older, than Anne, we've obviously got two unknowns, Todd and Anne. And who should we represent as X? Anne. How should we represent Todd? And so when it says that the sum of their ages is less than 15, how would I write that?
2 plus 5 equals...
Not equals. Is less than 15. And could she be 9 years old? Well, Anne is an X, so could we plug a 9 in here, class? No, that'd be like 23. Definitely not less than 15. So no, she could not be 9 years old. Do we get this inequality? Or perhaps x plus 5 is less than 15 for your inequality? Questions? Looking at number 29, says 3 times the number less 2 is greater than 10. Is 4 a solution? How did you represent the inequality, Noah?
3 and negative 2 is greater than 10.
And could 4 be a solution, Noah? No. If you plug in a 4, that gives you 12 minus 2 is 10. 10 is not greater than 10. It is equal to, so no. Do we have this for number 29? All right, and number 30. 5 less than, not is less than, 5 less than 4 times the number is greater than or equal to 3. And asking if 2 is a solution, how would we write that, Maddie? 5 less than 4 times the number is greater than or equal to 3. There we go, greater than or equal to, greater than with the line under it. 3, there we go. Did you have that written and just read it backwards? Okay, I should have had the greater than or equal to symbol. And could 2 be a solution, Maddie? Yes, it would give you 3, which is, yes, equal to 3, because you have that or equal to option. Questions on that? Remember, there's all kinds of different phrases that can be inequality phrases, but the key is the word is. And if it just leaves it at is, class is by itself means equals. But as soon as you put something with the is, like is not, that'd be not equal to, right? Is less than, is not as much as, does not reach. Think of short people trying to reach in high cabinets. Anyway, there's that whole page of things there, the previous page. Is at most, is below, is under, is no more than, is no less than, is at least, is over, is above. So all those different phrases. But again, you find the is, which means equals, and if there's a qualifier with it, that turns it into the inequality. Turn over to page 135 now. Page 135. And I want you to do numbers 9 and 10. They're in the review section. Do numbers 9 and 10 in the review section. They're on page 135. Very quickly rewriting those statements with inequalities. Page 135, 9 and 10. Let's see how we did. Number 9. 3 more than a number is at least 1. Well, 3 more than a number is super easy, Brecken. And then it says is, and if it said is 1, we would put, if it said is 1, we would have put equals 1. But it didn't say is 1, it says is at least 1. So that means we could be bigger than 1, right? Bigger than 1 would be at least 1, right? So bigger than, but at least, could it be 1? So if it could be bigger, or it could be 1, how would we say that with a mathematical symbol? There we go. And there's our statement. X plus 3 is greater than or equal to 1. Did we get that? Okay. And then looking at number 10. 2 more than a number is no more than 4. How would we write this, Maddie? Good. No more than 4 means it could be 4, because 4 is not more than 4. It says not more than 4, right? But certainly smaller than 4 is also not more than 4. So less than or equal to 4. Questions on this? Questions on this? If I were to graph an inequality, for instance, suppose we had the graph of x doesn't equal 4. How would I graph that on the number line? Noah? X cannot be 4. How would I graph that on a number line? Has nothing to do with those things.
And then you put a circle on the 4.
Good, circle on the 4, because it can't be that.
Then you fill in both sides.
Good, you're going to shade in both sides of the number line, including those arrowheads there. What if I had x is greater than 3? How would I graph x is greater than 3? Reckon? Good, shading everything that is greater than the 3, everything to the right of the 3. Of course, if we had x is less than or equal to 7, how would I graph that, Maddie? Okay? Could have filled in dot this time because equal to 7, we're not excluding the 7 from this group of points. Again, technically you're filling in every single dot as you go, but practically speaking, you've shaded the line. Questions on this? Clear desk except for a clean sheet of paper and pencil. One clean sheet of paper and pencil. Okay, everything else away. I'll let you know if you'd like to have a straight edge out for drawing number lines, that may be helpful to you. If you'd like to have a straight edge out, that may be helpful to you. Not necessary, but you know. Clean sheet of paper, pencil, possibly straight edge, everything else away. You may use graph paper if you want. You're certainly not obligated to do so. First and last name at the top of your paper, along with today's date. As long as it's clean paper, not paper with all the answers on it. Clean sheet of paper, pencil. First and last name at the top of your paper, along with today's date, which is 3/3/21. 3/3/21. The math guy was like, "Ooh, we can pull 3 out of everything." All right. Suddenly it's 1/17. Happy New Year. All right. 3/3/21. Today's date. Were you all born in 2007 yet? You were not. You were. You were.
Yes, I was.
You were. Okay. He's like, "How old am I?" Yeah, I was halfway through college at that. Halfway through my freshman year of college. And anyway, long time ago, back when I was young and in shape. All right. Let's take a look at the quiz together very quickly. Numbers 1 through 4, just write the meaning of each of those symbols. Numbers 5 through 7, set up a number line for each of those and graph what that would look like. Numbers 8 through 10, this is what we were practicing last night, where we're writing each of these as an inequality. And then for numbers 11 through 14, you're determining for each of those, could x equal -2? If it could, just write yes, and if not, write no. Be sure to show your work as to how you arrived at your conclusion. All right, you may begin. yeah. Let me go and collect those from you this time. And if you would go and take out your notes. If you would go and take out your notes, you can also take out your textbooks and turn to page 132. Page 132. Page 132 in your textbooks. We'll take a look at those quizzes tomorrow. Next section, your notes, solving inequalities. Solving inequalities. Understand that an inequality is a whole lot like an equation. In that an equation, there is a particular value of x for which this statement will be true. Right? I mean, if I gave you something like 3x negative 5 is equal to 7, we would say this is a true statement anytime x is 4. Right? And that's the only time it's true. We understand if instead of saying 3x minus 5 is equal to 7, if I said it's greater than 7, well, obviously then I need values that are greater than 4, wouldn't I? Had it said 3x minus 5 is less than 7, well, obviously then I need values that are less than 4. Does that make sense? The difference, two big differences. Number one, then your answer isn't just 4. It's not just a single number. It's an entire range of values. It's everything bigger than 4, or everything in this case smaller than 4. Does that make sense? That's one big difference. But that's really not a big difference in how you solve an inequality. For instance, this looks a lot like an equation, and in fact, we're going to solve it like an equation. We would move the 5 over, class, as a positive 5 to get 3x is not equal to, but rather less than 12. And we would divide both sides by 3, and we get x is not equal to, but less than 4. You're like, Mr. Jesse, that's just like an equation. Yeah, go and write that down in your notes. Solve it just like an equation, unless. Solve it just like an equation, unless just one difference. You see, what can flip an inequality on its head would be a negative. Because a negative would completely change sides of the number line, wouldn't it? Right? For instance, had this been a negative 3, well, then I don't need a 4 to make this equal. I would need a negative 4 to make it equal, wouldn't it? Right? So if this had been a negative 3, I wouldn't have divided by 3. I would have divided by a negative 3. But the whole premise then is now I'm getting a negative 4, but I also want the opposite side of the number line. So here's the unless. You solve it just like an equation, unless you multiply or divide by a negative. Unless you multiply or divide by a negative. Then flip the inequality. Unless you multiply or divide by a negative, then flip the inequality. So the difference here was the steps are still the same, right? Everything's still the same until I get right here. And then I have to flip that inequality around. Does that make sense? So that this would be my answer. Now, you say, well, Mr. Nadasky, I got this. We don't want a negative 3x. Why don't we just move the negative 3x over? Good idea. So one option here would have been to move the negative 3x to the other side as a positive 3x. In which case, the 7 would move over, class, as a negative to get negative 5, negative 7, negative 12. And notice now I'm dividing by a 3, and I don't have to flip the inequality. I get negative 4 is less than x. And you say, ooh, is that the same answer? Yes. Here's what makes it the same answer. What is the mouth eating in both cases, class?
X.
The x. And I know it sounds like a really elementary, juvenile way to explain it, but hey, it's easy. As long as the mouth is eating the same thing, they're equal to each other, right? So if I had something like, a 3 is greater than or equal to x, you're like, ooh, it really troubles my soul to see x on the right-hand side. Some people are really bothered by that. Some people are like, I don't care. Personally, I don't care. But some people are really OCD. No, the x belongs on the left. Okay, that's fine. Put the x over here and the 3 over here. But you better make sure the mouth is still eating, class, the 3. These are the exact same thing. As long as the mouth eats the right thing, we're good to go. So a couple ways to deal with the negative. If you have the negative x, you're like, I don't want to have to remember to flip that inequality symbol. Just move the negative to the other side. Now you don't have to worry about it. Unless you're one of those OCD people that really wants the x on the left, then you might as well just divide the negative and flip it. But that's the only difference. Otherwise, we solve them exactly the same way. You're on page 132. I want you to look at problem number 4. There is only one step on problem number 4 to solving it. We've got 7 plus x is greater than 4. What is the only thing that I have to do to solve this inequality? Maddie? To get a negative 3. Did I divide or multiply by a negative, class? No. I moved something, but I did not divide or multiply by a negative. So do I flip this inequality? No. You leave it as a greater than symbol. X is greater than negative 3. Make sense? Look at number 7 with me. Number 7. We've got an 8x. Negative 7 times the quantity x negative 1 is greater than or equal to 3. Well, treat it just like an equation. Brecken, what do I do first? Distribute. And when I distribute, now be careful, what are we distributing, Brecken? A negative 7. Okay, what do we get? There we go. We'll combine our x's together, Noah, to get 1x or just x. And at the same time, let's move the 7 over as a... And that's going to give me x is... And what symbol do I put in right here? Greater than or equal to. You don't flip it. You didn't divide by a negative. You just move something over as a negative, right? So literally, it's just like an equation, except I don't have an equal sign. It's a greater than or equal to sign. Look at number 11 with me. We've got a 3x plus 4 is greater than 2x plus 3. If this were an equation, we would say, oh, there's an x on both sides. I can't have that. We should get rid of, class, the little one. Guess what we're going to do? The same thing. It's just like an equation. We're going to get rid of, not Maddie. We're not going to get rid of Maddie. Maddie, which one are we going to get rid of? The 2x. And we move it over as a... Hey, and while we're at it, Maddie, let's also move the 4 over. That double switch thing that we've been doing off and on throughout the year. 3x negative 2x, of course, gives us x. And we move the 4 over as a negative 4. Positive 3 negative 4 gives us negative 1. And did I multiply or divide anything by a negative? No. So this greater than symbol just comes straight down. X is greater than negative 1. Do we see how it's just like an equation? Unless you multiply or divide by negative. Look at number 14. Number 14, what do we need to do first on this one, Noah? Distribute. And what do we get when we distribute on the right or on the left-hand side?
2x plus 6.
Good. So we have a 2x plus 6 is less than or equal to x positive 15. Then what do we need to do, Brecken? There we go. And then? There we go. X is less than or equal to 9, and there's our answer. Again, I would have moved the 6 at the same time I was moving the x, just save a step because I'm lazy, but not wrong. Good job there. Flip over to page 134. Flip over to page 134. Let's take a look at some of these together. Problem number 4, they have a 1/3 x is less than 4. Ooh, I hate fractions. I hated them in equations. I hate them in inequalities because they're just like equations. Multiply everything, class, by the LCD. Or, since it's just a single fraction times the variable, you could say multiply by the reciprocal, which is 3 anyway, right? So we'll just multiply everything here by the 3. When we do, we get is less than 12. Notice we didn't multiply by a negative. Nothing needs to flip. We treat it just like an equation. Look at number 10 with me. 2/3 x is less than 2. Now here, I could do the same thing, right? Multiply everything by the LCD. But remember what I said a moment ago. We've just got that one fraction times the variable. Maybe it would be quicker and easier, class, not to multiply by the LCD, but to multiply by the reciprocal. After all, we want to get rid of the 2/3 by dividing it from both sides. Let's multiplying by the reciprocal. And when we multiply by 3/2, remember this is technically 2 over. So now the 2's cancel and we get x is less than 3. Do we see how we're doing exactly what we did when we talked about solving equations? No difference. Look at number 6. 1 over negative 2x is greater than 3. Well, this is technically, we would say, where does the negative belong, class? In front of the fraction. And so to get rid of this negative 1/2, I should multiply by the reciprocal, which would be what? Negative 2 over 1 is the reciprocal of negative 1 over 2, right? Not a negative reciprocal, just a reciprocal. So if I multiply both sides by that negative 2, here, negative times negative, class, cancel to give me the positive, and of course the 2's cancel. You could argue the 1's cancel, though who cares? And I'm just left with x. And then right here, 3 times negative 2, class. But did you realize I multiplied by a negative? What do I have to do if I multiply by a negative? Change the inequality around. So instead of the greater than symbol, class, I need to put a less than symbol. Does that make sense? That's really the only thing we have to watch out for, is be ready to flip that symbol around. Look at number 7. Number 7, we've got a 2x is less than or equal to 8. Don't make this hard, Maddie. To get? Good, x is less than or equal to 4. Just divide away the 2. Look at number 11. Negative 2x is less than 23. What do we do, Noah?
Divide by 2.
I'm sorry?
Divide by 2.
Divide by 2.
Negative 2.
Divide by negative. Wait, divide by negative? Yeah, divide by negative 2. Negatives cancel, 2's cancel, leaving me with x. But because I divided by a negative, class, I got to flip the inequality. So not less than, class, greater than. Can I divide 23 by 2 anyway? So I'm just going to leave the improper fraction, but we slide the negative out front. And there's our answer. X is greater than negative 20, or is greater than negative 23 halves. Questions on 11. Look at number 13. We've got a 2x is greater than negative 7. What do we need to do here, Brackett? Good, divide by both sides by 2. Now, he did not say, class, divide by negative 2. It is not a negative 2 we're dividing. It's just a plain old 2. Do I flip the inequality? No. I happen to get a negative answer, but I'm not dividing by a negative. The 7 was already negative over there. So we do not flip the inequality. We still get a negative 7 halves answer like we did last time, but I didn't divide by a negative, so the inequality does not flip, unlike last time. Does that make sense? Do we see the difference? Okay, I've had students in the past like, anytime I get a negative, flip the inequality. No, not if you get a negative. If you multiply or divide by a negative. Look at number 15. Got a negative 3x is less than 12. Negative 3x is less than 12. What do we need to do here, Brecken? Divide each side by negative 3. What do we get for our answer, Brecken? x is greater than negative 4. Questions on solving inequalities. Look across the page at page 135. I want you to do numbers 5 through 8. Across the page, page 135, do numbers 5 through 8. Number 5, Maddie, what do we do? Perfect. On the next one, Noah.
5 minus 2 as a positive x is greater than -3.
Why didn't you flip the inequality? We got a negative.
Did divide.
We didn't divide by a negative, nor did we multiply by a negative. So, no, don't flip that inequality. Bracket, the next one.
3x plus 3 is less than 2x positive 7. Bring 2x over is a negative 2x. X plus 3 is less than 7. Bring the 3 over is a negative 3 to get x is less than negative 4. Or positive 4.
There we go, keep the sign of the greater. And there we go, x is less than 4. How about on the last one over here, Maddie? There we go. Questions on that one? Here's one for you. At your seats. Noah's got it. Maddie's got it. Brecken's got it. Noah, what did you do first?
I added the negative 4x and 3x.
Good. Combine like terms first. So we get negative 5x, positive 7 is less than or equal to.
Negative x plus 4.
All right. Then what do we do?
I brought the negative 5 over.
Good. This is the little x. So the best way to do this would be to bring the negative 5x over as a,
Positive 5.
and that'll give us
7 is less than or equal to 4x plus 8.
all right. Then we need to
Bring the 8 over
as a
negative
to get
negative
And then finally,
you divide the 4.
to get
-1/4 is less than or equal to x.
Now, if that troubles your soul and you're like, no, the x has got to be on the other side, how else could I write it, Noah?
X is greater than or equal to -1/4.
Good, you could also write it that way. How many got x is greater than or equal to -1/4? Now, did anyone get rid of the negative x instead of the negative 5x? It's not the best way to go because I highly recommend multiplying or getting rid of the little one, but let's suppose we move the negative 1x over, class, as a positive 1x. Well, in that case, I would get right here, class A, negative 4x plus 7 is less than or equal to 8. Then, class, we would need to move the 7 over as a negative to get negative 4x is less than or equal to 1. And then divide away both sides the negative 4. It is not a 4, it is a negative 4. And that would give me x is, flip it, greater than or equal to -1/4. Same answer, but you have to pay attention to that negative. You have to remember to flip it. If you get rid of the little one, you shouldn't have to divide by a negative. You shouldn't have to flip anything. And that's lazy. That's my style. No homework this evening. Have a wonderful rest of your day. We'll keep working on these in our next lesson.